Now in this lesson, we're going to discuss the derivatives of exponential and logarithmic functions to the base e, which are y equals to ln x and y equals to e to the x. So if we start by looking at the derivatives rule of these two functions, now the derivative of e to the x is e to the x. So basically, this function does not change by differentiation. The derivative of this function is the function itself. So the derivative of e to the x is e to the x. And the derivative of ln x is in fact 1 over x. So the derivative of the logarithmic function is in fact a rational function. It would not be a logarithmic function. However, if we look at these two here at the bottom, now this is the derivative with the chain rule. So, for example, if I have at the exponent of e a function of x instead of x, if I have it in the form e to the u, then the derivative would still be e to the u, the function itself, but we do not forget to multiply by the derivative of the expression inside e by u prime. And similarly here, if I have inside a ln, if I had u, a function of x, so here u represents a function of x. So if I have inside ln a function of x, similarly, the derivative would still be 1 over u, but we do not forget to multiply by u prime, the derivative of u. So just by solving some examples here, so if I were to find the derivatives of the following functions, so I have here the function f of x equals to e to the 7 x squared. So whenever you're finding the derivative of the function, the first thing you need to do is identify the form of the function. Now this function is in the form e to the u, and we know that the derivative of e to the u is e to the u, but multiplied by u prime, because here inside e I do not have x, I have a function of x. So u would basically be 7x squared, and the derivative of u would be, now we keep the 7 aside, we drop to the exponent, so that becomes 14, and we subtract 1 from the exponent. Now it's good to go back and revisit the video on the derivatives of standard functions. So now going back to the function, so the derivative of f would actually be e to the u, which is e to the 7x squared multiplied by u prime. So that would be 14x times e to the 7x squared. Now moving to the second function, f of x is 1 over e to the x squared plus 1. Now over here you could identify the function in the form 1 over u. Let me just write it here. So you could be identifying the function in the form 1 over u, and the derivative of the function in the form 1 over u is negative 1 over u squared, but we should not forget to multiply by u prime. However, over here, since we're dealing with u being an exponential function here, now an exponential function is a power. In fact, it has the form of a power. The power rules still apply. So over here, we could just move the exponential function to the numerator by, in fact, taking the opposite of the exponent, because we know that 1 over e to the a is e to the negative a. So that would actually make it easier to differentiate, because over here we would just be applying the same rule we've applied here, as consider it in the form e to the u. However, if you considered it in the form 1 over u and you found the derivative with the given expression without really changing it, both would actually lead you to the same answer. So over here, what we would be taking as u is negative x squared minus 1. So u prime would actually be, so applying the power rule on x squared, so that would be negative 2x, and negative 1 is a constant, its derivative is 0. So consequently, f prime of x would be e to the u times u prime. It's the same rule that we have here. So it's negative 2x times e to the negative x squared minus 1. Now you could wish to drop down the e to the denominator again, so that would lead you with negative 2x over e to the x squared plus 1. So if you have applied the rule of 1 over u on the function as given without really changing it, you should go back to exactly the same answer. However, looking at the third function, we have f of x to be x squared times e to the 5x. So over here, we'd actually notice that this is in the form of a product. This is in the form u times v, and we know that the derivative of u times v is u prime v plus v prime u. So over here, considering u to be x squared, u prime would be 2x. And considering v to be e to the 5x, then v prime would be e to the 5x multiplying by the derivative of the expression inside, which is 5, using the chain rule. So over here, going back to f prime of x, applying the product rule of the derivatives, so it's u prime times v, so it's 2x e to the 5x plus v prime times u, so it's plus 5x squared e to the 5x, and that would be the derivative of this expression. Okay, so moving to the last set of examples. Now over here we have f of x equals to ln of 1 plus x squared. Again, we need to identify the form of the function. Now this function is in the form ln of u, because inside ln I have a function of x. So the derivative of ln is usually 1 over u, the derivative of ln u. And of course, we should not forget to multiply by u prime, the derivative of the function inside ln. So over here, u is 1 plus x squared. That's the function inside ln. So u prime would in fact be 2x. The derivative of 1 is 0, and the derivative of x squared is 2x, using the power rule of derivatives. So f prime of x would actually be u prime over u. So it's 2x over 1 plus x squared. Now in this next function, we're dealing again with a product. So over here I have u to be e to the x. So u prime is e to the x. And v to be ln x, so v prime is 1 over x. So applying the product rule of the derivatives, the one we've just applied just a couple of minutes ago, which is u prime v plus v prime u. So f prime of x is u prime times v, so it's e to the x ln x, plus v prime times u, which is e to the x times 1 over x, which is e to the x over x. And similarly for the last one, now that is an easy one. So over here, this is in the form ln u, where u is 4x, so u prime is 4. Again, using the same rule we applied here. The derivative of ln u is 1 over u times u prime, so that's u prime over u. So f prime of x would actually be u prime, which is 4 over 4x, which is 1 over x. So that is it for the derivatives of exponential and logarithmic functions of base e. Of course, in a following lesson, we're going to be discussing derivatives of exponential and logarithmic function of any base, not just this particular base, which is e.